This is the foundation tier motion revision video. The first thing you need to know is the difference between speed and velocity. Speed is a scalar. It just tells us how fast something is going, not the direction it's traveling. Velocity is a vector. So S for scalar, S for speed, V for vector, V for velocity. It tells you the speed and the direction. To show the direction is different, velocity can be positive or negative. There are 4 speeds you have to learn. You have to know that walking is 1.5 meters per second, running is 3 meters per second, cycling is 6 meters per second, and the speed of sound is 330 meters per second. They may ask you to compare it. So, for example, how many times faster is cycling compared to walking? So it's 4 times faster. Those sort of things. First calculation is distance, speed, and time. You do this in maths. So distance equals speed times time, or speed is distance divided by time. The common units for physics is distance in meters, speed in meters per second, and time in seconds. Distance time graphs. So any diagonal line on a distance time graph shows that the object is moving at a steady speed. If you get a horizontal line on a distance time graph, it is stationary or stopped. The steeper the gradient, the greater the speed. I always think of it like a slide. So you'll go faster on this slide than you would on this slide. You need to know how to calculate acceleration. So calculating acceleration is change in velocity divided by time. The mnemonic is you can't change a very angry teacher. Velocity is measured in meters per second. Acceleration, meters per second squared. And time is measured in seconds. Velocity time graphs look like distance time graphs, but mean very different things. A diagonal line on a velocity time graph means acceleration if it's going upwards, and deceleration if it's going downwards. If you get a horizontal line above 0 on a velocity time graph, it means steady speed. A stationary velocity time graph will be down here on the 0 line. Similarly to distance time graphs, the steeper the gradient, this time the greater the acceleration. This equation is on the formula sheet. V squared minus u squared equals 2as. The letters mean velocity, final for V, and initial or start velocity for u, a for acceleration, and s for distance. You're given them on the formula sheet. Just put the numbers in, work out the side you know everything on, and then rearrange as you would in maths. You get 1 mark for putting the numbers in the correct positions. Stopping distance is thinking distance plus braking distance. Thinking distance can be increased if the driver is tired, distracted, or using drugs or alcohol. Braking distance, to do with the road or the weather, can increase if the road is wet, icy, or if the tyres or brakes are worn. The average reaction time in humans is 0.2 to 0.9 seconds. There are 3 laws that you need to know. Newton's first law is an object will remain at rest unless it's acted on by an unbalanced force. So that football will stay still unless a force from the foot or the wind makes it move. It will then continue to move in that motion unless acted on by another force. So someone could get a different direction, or if it hits the back of the net. Newton's second law is an equation. F for force in newtons, m for mass in kilograms, a for acceleration in meters per second squared. The mnemonic for this one is fit men's arms. Newton's third law is when 2 objects interact, they make a pair of forces that are equal in size and opposite in direction. So wherever you're sitting on right now, you're putting a force downwards by gravity and you pushing down, but your chair or whatever you're sitting on, bed, wherever you are, is pushing on the same force back in the opposite direction. So you are technically demonstrating Newton's third law. Terminal velocity is the maximum speed an object can travel when the forces are balanced. So at the beginning, when someone jumps out of an aeroplane, the only force acting on them is gravity pulling them down. As they speed up, slowly their air resistance increases. When the air resistance and the gravity are balanced, the forces are the same, so the speed is constant. Notice the size of the arrows, all right, are the same when it's going at a constant speed. That's terminal velocity. The force of gravity does not change during this fall because you do not change planets midway through a parachute jump. The required practical here is an acceleration one. It's when you would use a trolley and a pulley. You'd add a 0.1 Newton weight to a wire. You'd release the weight and start the stopwatch. You'd record the time at every 10 centimetre marker. You'd then calculate the acceleration of the trolley, and you'd repeat every 0.1 until you get up to 0.5, because remember, 5 is the magic number for practical results. That's the end of the motion video.